I'm MeshCentral, and in this video we're going to take a look at a short history of Intel active management technology. Intel AMT, or Intel Active Management Technology, has been around since I think around 2006 is what I can find as the earlier versions. And since then, it's been evolving quite a bit. The latest generation, as I'm recording this, that I think is available is version 14. And so it's gone from version 1 to version 14, roughly at a version every year. So it's been around 13, 14 years since Intel AMT has been first brought to market. And so I want to take a quick look at the history of AMT. And this is going to be a super quick look, but why, how it got started and the main features as it evolved. So I'm going to start by going to this slideshow I have, or these sheets, and everything really starts with the network adapter. Intel used to be one of the leading vendor of network adapters for Ethernet. So you used to buy a PC, it had PCI slots, but usually your PC would not come with built-in Ethernet, and so you had to buy an extra card, put it in, and then you would network your PC. And of course, the networking was at the time not used in the home at all. It was used only in corporate networks. And so not all computers needed it. And that hardware used to be pretty expensive. But as it got cheaper, then it got built into the motherboard. But also as companies competed for selling these network adapters, then they started putting extra features on them. And so one of the features I'm familiar with, because I worked on some of it, was crypto accelerator network adapters. So Intel and others would put some kind of AES or triple DES or accelerators. And as the network packets would flow through the network adapter, the network adapter would be given the keys to encrypt the traffic and then send it out. And so it would offload the main CPU and take the traffic encryption and put it on the network adapter. For one thing that was always odd about this is when you received an encrypted traffic, you need to get the encryption key, and so usually the traffic would go to the OS and then back to the network adapter and so on. But on the outbound path, that was really fast. In any case, so that was a way for network adapters to differentiate themselves. It's that not only are we faster, but we do security encryption or encryption offload. But another way that you could differentiate yourself from the competition is by putting management features inside your network adapter. And so some companies did this in some different ways. And the general idea is that you have this Ethernet adapter that can talk externally. And so you can not only relay traffic to the operating system, but you can present things like a web interface to so that people connect through the to this machine, but instead of routing the traffic to the operating system, then the network adapter would respond on its own and send back, a web interface, for example, on a certain port or things like that. And then you could do stuff like you could have special network filters, like, warn me when this type of traffic shows up, or block this type of traffic based on some kind of filtering. So that's one thing. The other thing is that you could have, when you plug in the adapter inside the PCI slot, well, you could say to the operating system, I'm a network adapter. But you could also say to the operating system, I'm also a serial port. I'm also a mouse. I'm also a keyboard. I'm also a disk drive. I can do power control. So you can pretend to be all sorts of things that you're really not. And so this is kind of useful. For example, you can present yourself as a serial port. You can say, I'm COM4, COM4 colon. And so what happens is that you can when data is sent to that communication port, that COM port, you can wrap it up and send it out the network. Or when somebody sends you traffic, you decrypt that traffic and takes those bits and send it up to the serial port. So now you have kind of like a network serial port that can be useful for a whole bunch of stuff. Like if your BIOS supports sending the BIOS screen in serial port, but also for keyboard for kernel debugging. There was a whole bunch of different things where, well, instead of having a normal serial port, if you have a network one, you can access it from all over the world. And so that can be useful. If you're a disk drive, that's interesting, because if you pretend to be a CD-ROM drive, then you can ask the operating system, well, boot on my CD-ROM drive, the CD-ROM drive that I pretend to be. Now, of course, when the OS tries to access that CD-ROM drive, what you do is you don't know what to do. You're not actually a CD-ROM drive, but what you do is you take that command and send it out over the network to a piece of software that would know how to answer. And so you have a piece of software that looks like a virtual CD-ROM, and it would answer back the commands, and the commands would go back to the operating system. So you can virtualize, a disk drive, and same for power control and so on. So even if you didn't have that much cooperation from the operating system or the BIOS or so on, there's a lot of stuff that these network adapters can do management-wise that, you can just pretend to be some device or, and you have access to the network. So that's how really AMT got started, is not really into, not in this form factor, but kind of the general idea was, let's put manageability features inside the network adapter. Also, one of the wonderful things about the network adapter is that it tends to, in some cases, stay on even if the rest of the computer is sleeping or in soft off. So it's still powered, and very often what these gigabit or Ethernet adapters will do is that when they're sleeping, they're going to downspeed their port to 100 or 10 megabits per second. So you don't need that much speed when the computer is sleeping. So and the nice thing is you want to save a lot of power, and so one way to save power is to just drop your speed. So what you'll notice is that in some modern Intel AMT platforms or any platform, if you connect your Ethernet port to a switch that has a light to indicate the speed, you may notice that when the computer is sleeping, the speed will go down. The switch will switch to a lower speed. But anyway, even at that lower speed, you can receive wake-on-LAN packets. You can receive requests to do things, including waking up the PC. And so you can do that. There was a long time ago, where they had an extra connector in the back of these network adapters, because the PCI bus, I believe, did not allow you to wake up the PC. So it wasn't in the specification. So what they did is they put an extra connector and then an extra connector on a motherboard, and you had a little wire that you had to attach in addition to the Ethernet card. And so when a wake-on-LAN packet or some management packet would tell you to wake up the PC, then it would use that little cable to wake up the computer. So anyway, that's kind of how it got started. Now, of course, modern motherboards have Ethernet almost always built in, because it's gotten fairly cheap to add that in, and it's fairly universally used. And so the nice thing is the integration of Intel AMT into the computer has gotten much better. So one thing that's going on here is that usually you have your IOs in the front, you have your PCI cards, and you have your CPU, your memory, and your power supply stuff is here. And then you have what they call the ICH, and this is where the modern Intel manageability engine is. So it's located inside this ICH chip. So it can stay on at very, very low power, even if the CPU is off, even if the memory is off, and it can receive commands from the gigabit adapter. Also, the thing is you can power this off and have just the gigabit adapter be on at low power and at low speed. And then when the Ethernet adapter receives something that's relevant to the management engine, it filters it out and then wakes up the management engine, the ICH, and sends it the command. So that's how AMT works. So obviously, if you want AMT to be on while your computer is sleeping or in soft off, you still need to have the motherboard powered with the power connectors, is like over here. But otherwise, the CPU and memory will be completely off. A long, long time ago, interesting fact, starting with like AMT 2 and 3, what would happen is that when the computer was sleeping but the ME was on, the ME would use some of the main system RAM. And so what it would do is it would keep the first DIMM, the first slot of the memory powered on, but only when the ME was on. So it was possible for the gigabit Ethernet to be on, but the ME to be off and the CPU to be off, and then all the memory would be off. But if you were to wake up the ME for any reason, you also had to wake up the first slot of RAM. So this is the very old versions of AMT. Now, more modern versions of the board, the memory controller is, it used to be in the ICH, and so you could do this trick of waking up only the first DIMM. But modern versions of boards have the memory controller completely inside the CPU. And so what happens is that you have the CPU here, basically, and the memory talking directly to each other. There's no intermediate chips anymore. And so if you power down the CPU, you've also powered down your memory controllers. And so there's no way for the ME to now kind of use one of these RAM banks without the CPU being turned on. As a result, now the ME has its own little memory blob that it uses inside this chip, and then everything else here can be off. But you will have to understand or appreciate a little bit how there is some extra wiring and design that has to go into having a motherboard that can be managed out of band, that can be managed regardless of the operating system. Okay, so that's good. So we have the first versions of AMT that obviously this is not an actual picture here of an AMT1. I could have found one, but like it would be a really old board. But the first versions had things like TLS support. It has a built-in web page. So what you could do is you could activate AMT, and then once it's enabled, because it's not activated by default when you buy these boards or the mobile platforms. But when you do activate it, then you can access this AMT feature through a remote website. So you don't need any special tools or anything. The remote website is quite limiting. It doesn't allow you to do very much, but you can just take any normal browser and browse to port 16992 with HTTP or 16993 with HTTPS. And then when you access these ports, the traffic will go to the management engine instead of the operating system, and you will see this web page. Another thing to note is that the operating system doesn't know that the management engine, that it's not receiving the connections. Obviously, if you were to build an application and listen on 16992 or 16993, expecting a connection for a video game or something like that, well, AMT is now filtering these ports and sending them over to the management engine. So anybody who's connecting, you won't get the connection. So you just have to be, now the operating systems know this, and so they won't have your application randomly listen on that port. But if you are a server piece of software, you obviously don't want to listen on any of the Intel AMT ports. 16992 to 16995 are those ports. Anyway, so AMT starts out a long time ago, has a built-in web page, has a bunch of features, and one of the features it has is the serial port. Just like I talked on slide 2 right here, where the network adapter can pretend to be a serial port. Well, yeah, AMT does that, and it did that since the beginning. So you have a new COM port. Usually you have COM 1, and then that would be the normal communication port for your platform if you have a serial port in the back. And then you have something like COM 3 or COM 4, which would be your Serial-over-LAN port, or the port that AMT presents. Now, obviously, you don't have a physical port associated, but you have programs like Mesh Commander that can connect to AMT. If you go to the, it says remote desktop here, but what I meant to say is you could go to Serial-over-LAN, and then you see a screen that looks like this. It's text-based, and you can go into BIOS and look at the text-based BIOS screen. You can use PuTTY. You can use any tool that hooks up to that serial port, and when you send data in, the data will show up on Mesh Commander, and then when you type stuff in Mesh Commander, it will go through to the local port on the platform. So useful for a whole bunch of stuff, but of course the main one is that you can tell AMT to reboot the platform and then to present options or flags to the BIOS that will indicate to the BIOS, please send a VT100 text-based version of your BIOS down the COM port, the AMT COM port, and that's how you see the BIOS screen in terminal on these platforms, these older platforms. Okay, so these are platforms that don't have KVM already. They just have the Serial-over-LAN. So that's old days. Now, moving forward, one of the major innovation that's going to be very relevant in the future starts with AMT4. AMT4 is the first platform, the first Intel AMT that's put in a mobile platform. It was Santa Rosa at the time, I believe. And so it's the first AMT that is going to go inside a laptop. And of course, the problem with laptops is they go all over the place. And so they're not expected to be connected on a corporate local network. And so now what do you do when you have a technology that is kind of designed for local networks like this, and now you have it in a laptop? Well, what you have to do is, instead of having the management platform contact you, you have to contact the management platform. You have to reach out to the platform. And so starting with AMT4, there's something called Client-Initiated Remote Access, or CIRA. And the other, like the friendly name they had for this, although it's never really caught on, is called Fast Call for Help. So that was like the branding they associated with CIRA. So they said, well, so if you hear Fast Call for Help, it's the exact same thing as CIRA. So these platforms can work starting with AMT4, you can work as just a normal AMT where you receive connections on the local network from management platforms. But you can also be set up to reach out and connect to a remote cloud server. And so the remote cloud server is also called MPS, the Manageability Presence Server. And so that would be the name given to a server that receives CIRA connections. And by the way, MeshCentral fully supports this role. So MeshCentral has a port, typically it's by default 4433, and that is a port that is that can receive CIRA connections. So it understands that protocol, the encryption, the certificates, and so on. And so it has this special port to receive Intel AMT connections that way. You can, if you don't use this feature, you can turn off the MPS server or port 4433 on MeshCentral. And in the future, I would love for them to modify the firmware here so that a little bit like the Mesh agent, it would be nice if in the future the AMT would connect on port 443 of MeshCentral, just like the Mesh agent does. And so I wouldn't have to have a separate port for this kind of stuff here. But anyway, for now, it needs its own port because this protocol is binary, it's not HTTP based, and it needs a special certificate. Okay, so by the way, Sierra starts with AMT4. Not all platforms after AMT4 have Sierra, but most of them do. So at the beginning, it's kind of spotty. It's mostly mobile platforms. But as time goes on, pretty much all AMT versions have Sierra all the time. Like all the different SKUs have Sierra all the time. Okay, so another big milestone. Oh, by the way, AMT4 is also the first one to have Wi-Fi enabled AMT. So now you have both. You can both have AMT managed on Wi-Fi and AMT on the Ethernet. Now, Wi-Fi is tricky because AMT also needs to kind of, if the platform is sleeping, AMT needs to know what Wi-Fi profiles you have and be able to load up the driver, the Wi-Fi driver, and be able to start associating with access points, even when the computer is still sleeping or and so on. So that's another major change here, starting with AMT4. Now, AMT6 is really the one that is also super interesting to me because it has KVM for the first time. And so AMT6 is the first version that really goes or departs from the original point I kind of made, where you have a network interface and it just, kind of can do a lot of stuff with just a little bit of BIOS help and otherwise no other platform help at all. So this is great, but in order to do KVM, network adapters would need to reach out and grab like screenshots from the video adapter. And so this typically is not something you would do or you would see a network interface do. But since AMT is integrated inside the platform, and also since increasingly what would happen is that the graphics would also be integrated inside the CPU. So normally graphics were, an add-on card, and so you had NVIDIA, AMD, and I remember you had Matrox up in Canada and so on. So you had a whole bunch of 3D Max or something. Anyway, you have a whole bunch of different video cards that you add on. Now, what happens is that increasingly platforms came with a built-in network adapter. And so it was fairly straightforward, I would imagine, to now have the management engine ask the built-in network video adapter, please give me a screenshot of the current screen, and then it would compress that or resize it and so on, and then it would send that over the network to a management console like Mesh Commander and MeshCentral. And so now you can see the screen for the first time starting with AMT6. And also it was fairly easy for the network adapter to pretend to be a mouse and pretend to be a keyboard. And so now you have a network adapter, AMT, who now pretends to be a USB mouse and a USB keyboard. Now, one interesting point about that is the operating system needs to be somewhat responsive that, there's this keyboard and mouse that just showed up on the system. I need to load up the proper drivers and make use of them. So in theory, you could have an operating system that you would be able to see, but because it's misbehaving in some way, you wouldn't be able to move the mouse or type on the keyboard because this operating system would not take into account the mouse and keyboard devices presented by AMT. Okay, but that's super duper amazing, starting with AMT6. And AMT had to also deal with things like, well, what if you have multiple displays connected? And so, built-in graphics used to support 2 displays. Now they support 3 displays at the same time. So AMT has to be able to allow you, as a remote management software, to be able to select which screen you want. AMT so far does not allow you to view all monitors at the same time. So if you have 3 different monitors showing 3 different images, you can't see all 3 monitors at the same time on the remote machine. AMT can only grab one of the 3 monitors at any given time. So usually you have a switch at the bottom of Mesh Commander here or MeshCentral, and it allows you to pick which screen. So anyway, AMT 6, I think that's one of the most pivotal point is really the addition of the KVM. Also, one of the reasons why this is so pivotal is because IP KVM devices cost a lot of money. They cost $200, $300, $400 and up. And so even per port, even if you have switches that have lots of different ports, or if you buy a Pi KVM or something like that, these devices that allow you to remotely view the screen and have a mouse and keyboard access cost a lot of money per port. And so the nice thing about Intel AMT is that for relatively cheap, you get the same feature. It's now baked into the platform. It doesn't cost that much more, and you get remote IP KVM support. So yeah, AMT 6 definitely probably after the launch of AMT, and one of my favorite addition. But of course, AMT 4 with Sierra also going to be extremely pivotal as we go to cloud-based management. So lastly, AMT 6.1, there is another big change, and this is how we activate AMT. And I'll make another video on this, but that's where before AMT 6.1, we had something called small business mode, we had enterprise mode, and they had pros and cons to each of them. But starting with 6.1, the activation completely changes, and now we have ACM, or admin control mode, and we have CCM, client control mode. And so this is ways you can activate AMT. So I'll have another video on that, but just to give you a quick overview of the difference here, ACM is adversarial to the operating system. So when you have AMT and ACM, it's monitoring the operating system on behalf of remote IT or so on, so that if the operating system does something bad, AMT can step in and try to mitigate it. With CCM, basically you have AMT working along with the operating system. They're buddy-buddy, they're friends, and AMT does not kind of monitor, it just asks what the OS wants to do and does it. So they're very fundamentally different ways of activating AMT. So the other thing I want to show, if you go on Wikipedia, there are pages you can search for Intel AMT, actually right here. This is the article on Intel Active Management Technology. I think I actually put this screenshot of the AMT web UI like ages ago, and it's still there. But otherwise, the articles and the pages have changed enormously over the years here. Now, you can take a look at the history and the applications and the usages of AMT. But the history here has an article on AMT versions. And you can see starting with version 1 up to version 14. And then there's a comparison of Intel AMT versions and their features on the left. And what you'll note is AMT 4 is this column right here, and AMT 6 is this column right here. And 6 is the one that you'll notice here, there's a bunch of stuff that changes, that switch from no to yes at AMT 6. And the biggest one is really the KVM right there. And then host-based provisioning, this is what I was talking about, the CCM to ACM. And so that one is 6.1 and up, that changes. And then on AMT 4, this is where you have Sierra. There goes fast call for help, also known as Sierra, right there. And that one switches to yes there. And so that's going to be like a pivotal technology for AMT as we go to cloud-based management. As software like MeshCentral wants to manage these devices out of band, even regardless of where they are on the internet. That's where Sierra becomes super, super nice. That's it. Otherwise, I think that's a fairly quick recap of Intel Active Management Technology. I've been working on it for a long time. Obviously, I work on MeshCentral, I work on Mesh Commander, and those are two big open source software that make use of AMT. And so, yeah, I've been involved in it for a long time, and hopefully the history will keep going on this technology. Take care. Thank you very much.